Next on the list is the Grand Design Spiral Galaxy, known as the Phantom Galaxy or M74, located approximately 32 million light-years away in the constellation Pisces. This galaxy exhibits a textbook spiral structure with prominent sweeping arms that extend outward from its bright central core. The James Webb Space Telescope has captured these arms in exquisite detail, revealing them in rich shades of orange, indicative of regions dense with star-forming material. These dusty arms are teeming with the ingredients for new stars, creating a dynamic environment for stellar birth. At the core of the Phantom Galaxy, Webb's image shows a blue light haze, which signifies the presence of older stars. This central region is densely packed with star clusters that collectively contribute to the galaxy's brightness, forming a brilliant, glowing hub. This is not the first time the Phantom Galaxy has been imaged. The Hubble Space Telescope had previously captured striking views of M74 invisible light, showcasing its classic spiral structure and highlighting the distribution of stars and star-forming regions. In Hubble's images, the arms of the galaxy glow with blue light from young, hot stars, offering a vivid glimpse into the regions where star formation is most active. However, Hubble's observations were limited by its inability to penetrate the dense clouds of dust and gas that obscured parts of the galaxy's inner structure. In contrast, JWST's infrared capabilities allow it to see through these dust clouds, providing an unprecedented look at M74's inner workings. This enables astronomers to pinpoint specific regions where new stars are being born and to analyze the chemical composition of these areas in great detail. On July 27, 2022, the James Webb Space Telescope captured an extraordinary view of Jupiter, revealing details that had never been seen before. In Webb's images, Jupiter appears in enchanting shades of light pink, dusky blue, and white, colors enhanced by the telescope's infrared capabilities, which can penetrate the planet's thick atmosphere and provide insight into how different cloud layers reflect sunlight. The bright equatorial zone stands out prominently in these images, its high-altitude hazes scattering light and creating a striking contrast. Jupiter's iconic Great Red Spot, a massive storm larger than Earth that has been churning for over 350 years, is clearly visible. Interestingly, in Webb's view, the Great Red Spot appears white rather than red due to the bright reflection of sunlight off high-altitude clouds in the infrared spectrum. One of the most exciting features Webb uncovered was Jupiter's spectacular auroras, glowing brightly at the planet's poles. These auroras are caused by charged particles from the Sun interacting with Jupiter's powerful magnetic field. Because Jupiter has a much stronger magnetic field than Earth, its auroras are far more intense and extend over vast areas of the poles. Webb's infrared vision also provided an impressive view of Jupiter's faint rings, which are far less prominent than Saturn's, but still fascinating. These thin, dusty rings, first discovered by the Voyager spacecraft in 1979, are made mostly of small particles of rock and dust. They are believed to originate from impacts on Jupiter's moons, where material from these collisions has spread out to form the delicate ring system. Webb's images of Jupiter not only showcase its beauty, but also offer a wealth of information about its atmospheric dynamics, magnetic fields, and the forces shaping its environment. This tiny red dot you see is Earendel, the farthest star ever discovered in the universe, lying near the edge of time. The light from Earendel has traveled an astounding 13 billion years to reach us, but due to the expansion of the universe, its true distance is much farther, about 28 billion light-years away. This incredible discovery is a result of a cosmic coincidence, where the alignment of a massive galaxy cluster in the foreground has gravitationally lensed Earendel's light, magnifying it and allowing us to see this distant star. Earendel was first identified by the Hubble Space Telescope. Hubble spotted its host galaxy, which was being gravitationally lensed, forming a stretched and bent structure scientists named the Sunrise Arc. Within this arc, they detected something unusually bright, far too small to be a galaxy. Upon further study, astronomers determined that this bright object was magnified by a factor of at least 4,000, indicating that it was an extremely distant, gravitationally lensed star. Based on Hubble's observations, Earendel was classified as a massive B-type star, about 1 million times brighter than our Sun and more than twice as hot. However, when the James Webb Space Telescope observed Earendel, it revealed something new. Webb's advanced infrared capabilities detected hints of a cooler, redder companion star near Earendel, which had not been visible in Hubble's earlier observations. This discovery opens up exciting possibilities for studying this ancient stellar system. Earendel's discovery is monumental because it might provide our first glimpse of a population 3 star, one of the very first stars to form after the Big Bang. Population 3 stars have been the focus of astronomers' attention for years, as these stars were made entirely of primordial hydrogen and helium and may have played a key role in the evolution of the early universe. Astronomers expect that Earendel will remain magnified for years, allowing the James Webb Space Telescope to conduct more detailed observations. These follow-up studies could help unravel the precise nature of this star and its companion, offering us a rare window into the earliest eras of cosmic history. While Earendel represents a star born near the dawn of time, this image shows a protostar on the verge of beginning its life. L1527, nestled within a dark cloud. This protostar is hidden within a striking hourglass-shaped structure with a dark line across its center, representing a protoplanetary disk. Light from the forming star leaks through the disk, illuminating the surrounding gas and dust. In the near-cam image, the colors blue and orange represent different layers of dust. Blue areas signify thinner dust, allowing more light to escape, while the orange regions represent denser pockets of dust, where light is more absorbed. This color contrast beautifully illustrates the complex interactions between light, gas, and dust as the protostar matures. L1527 is around 100,000 years old, making it a very young Class 0 protostar, one of the earliest stages of star formation. At this stage, it has not yet begun nuclear fusion, the process that powers fully developed stars. As L1527 continues to accumulate mass, the material in its core will compress, eventually reaching the critical temperatures needed for nuclear fusion to ignite. This will mark its transformation into a fully fledged star. This view of L1527 offers a rare glimpse into what our Sun and solar system may have looked like in their infancy, providing valuable insights into the early stages of star formation and the processes that lead to the creation of stars and planets. Uranus is one of the least explored planets in our solar system, with only Voyager 2 having flown past it. However, Webb's detailed images of this ice giant reveal features that were previously obscured. One of the standout details is the planet's vibrant rings, which had only been imaged by 2 other facilities, Voyager 2 and the Keck Observatory with advanced optics. Webb's infrared capabilities allow it to capture the brightness and structure of Uranus's rings, which are harder to detect in visible light. Among these is the elusive Zeta ring, which has now been clearly resolved, giving astronomers a better understanding of its characteristics. Uranus has 13 known rings, and 11 of them are visible in Webb's image. Some of the rings are so bright in the infrared that when viewed close together, they appear to merge into a single, larger ring. Another fascinating feature captured by Webb is the ice giant's polar caps. Uranus is unique among planets in that it rotates on its side, with its axial tilt of 98 degrees. This extreme tilt causes Uranus to experience very unusual seasons, with its poles undergoing long periods of constant sunlight, followed by years of complete darkness. Currently, it's late spring for Uranus's North Pole, which is visible in Webb's images, and the planet's northern summer will arrive in 2028. In contrast, when Voyager 2 visited Uranus, it was summer at the southern pole, which is now in complete darkness, out of view, and facing the vastness of space. Webb's image also captures several of Uranus's 27 known moons, including some smaller moons that appear close to the rings. Remarkably, this detailed image of Uranus was captured during a short 12-minute exposure using just 2 filters, demonstrating that this is only the beginning of what Webb can reveal about the mysterious ice giant. This is ARP 142, affectionately known as the Penguin and the Egg. In this stunning image, we witness the cosmic dance of 2 interacting galaxies, NGC 2936 and NGC 2937. While our Milky Way and Andromeda are separated by 2.5 million light-years, the Penguin and the Egg are just 100,000 light-years apart, which is relatively close in astronomical terms. The Penguin galaxy, originally a spiral galaxy like the Milky Way, has become significantly distorted due to its gravitational interaction with the Egg, which is a more compact, elliptical galaxy. Over the next several hundred million years, these galaxies will merge into a single entity, creating a dramatic, though gradual cosmic event. This image vividly captures the intricate interaction between the 2 galaxies. The Penguin galaxy, with its tail filled with gas, dust, and newly formed stars, has been transformed by the encounter. A bright blue haze surrounds it, indicating star formation. The beak of the Penguin is rich in gas and dust, and it is the brightest starburst region, where active star formation is happening. The eye of the Penguin, seen near the galaxy's center, reflects the original spiral shape before the interaction with the Egg. The Egg, by contrast, is an elliptical galaxy with aging stars. Its compact structure and lower amounts of gas and dust have left it less distorted than its counterpart. A third galaxy, a spiral in the top right, attempts to steal the spotlight in this image. Though it appears prominently in this composite image, it's much closer to us and is not part of ARP 142. As these galaxies continue their cosmic merger, they will create new regions of stars and planet formation. This duo of interacting galaxies commemorated the second science anniversary of the James Webb Space Telescope in July 2024. There's a big crisis in cosmology, and this image taken by the Webb telescope confirms it. It shows galaxy cluster G165 acting as a massive gravitational lens, bending and magnifying light from distant objects behind it. But something surprising caught astronomers' attention in this image: 3 mysterious dots of light that weren't visible in previous Hubble images from 2015. These 3 points of light, now clearly visible in the Webb images, turned out to be a Type 1a supernova in a distant background galaxy. Named Supernova Hope, this exploding star has been gravitationally lensed by the cluster G165. What we see are not 3 separate supernovae, but multiple images of the same supernova whose light has traveled along 3 different paths, bent by the mass of G165 lying between us and the distant galaxy. This is a stunning example of gravitational lensing, where light from a background object is bent by the gravity of a massive foreground object, resulting in multiple magnified images of the same event. What makes Hope especially significant is that it is now the most distant Type 1a supernova ever observed. Type 1a supernovae serve as standard candles in cosmology, objects with known intrinsic brightness, allowing astronomers to accurately measure distances across the universe. These measurements are key to determining the Hubble constant, the rate at which the universe is expanding. However, there's a growing tension in cosmology. Webb's observation of this supernova has helped astronomers calculate a Hubble constant of 75.4 kilometers per second per megaparsec. This value, derived from the local universe, is in conflict with the Hubble constant measured from the early universe, using data from the cosmic microwave background, which gives a lower value. This discrepancy has led to the so-called Hubble tension, suggesting that there might be something fundamental missing in our understanding of the universe's expansion. The discovery of more distant supernovae, like HOPE, will be crucial in refining these measurements and possibly resolving this tension in cosmology. One of the most breathtaking results from the James Webb Telescope came when it peered at the edge of time. Within weeks, the telescope observed massive galaxies at a record-breaking distance, challenging our current models of astrophysics. This is JADE's GSZ 14-0, the most distant galaxy ever observed, existing just 290 million years after the Big Bang. This means that its light has been traveling for approximately 13.5 billion years to reach us. The galaxy is not only distant, but also remarkably bright and large, measuring over 1,600 light-years in diameter. This luminosity suggests that it is producing light through young stars rather than a supermassive black hole, which is typically responsible for the brightness of quasars. The presence of ionized gases like oxygen indicates that multiple generations of massive stars had already formed and died before we observed this galaxy. The existence of such a large and luminous galaxy so soon after the Big Bang suggests that galaxy formation occurred much more rapidly than previously thought. This finding challenges existing models that predicted slower formation rates during this period. These amazing images from the James Webb Space Telescope show us the beauty and mystery of the universe like never before. Each image takes us deeper into space, revealing stars, galaxies, and nebula in incredible detail. They remind us that we are just a small part of a much bigger story, a universe that stretches beyond our imagination. Looking at these wonders, we can feel connected to the cosmos, realizing that the same forces shaping distant stars also shaped us. The universe is vast, and these images let us glimpse into the endless beauty and our place within it.